In this video, we will be looking at Unknown Angles Topic 4, Proofs. These are just some basic proofs regarding parallel lines, angle bisectors, certain properties such as reflexive, addition, subtraction, transitive, things like that. So we're going to start with a reminder about parallel lines and the types of angles that they form. If parallel lines are cut by a transversal, then the alternate interior angles are congruent. If parallel lines are cut by a transversal, then alternate exterior angles are congruent. Again, if parallel lines are cut by a transversal, then the corresponding angles are congruent. And then last but not least, if parallel lines are cut by a transversal, then the same side interior angles are supplementary. And remember that supplementary means that they add to 180. We can also think about the reverse of that, or the converse of that. If two lines are cut by a transversal and special pairs of angles are congruent or supplementary, then the lines are parallel. So we're going to dive right into our first proof. Given that line AB is parallel to line GD, prove that angle BCH is congruent to angle GHC. So we know AB is parallel to GD. And our goal is to find the angle BCH, I'm going to put a little dot there, that's what we want to find, is congruent to angle GHC. And again, a little dot. We want to show that those are congruent. So I'm going to start by making my T-chart. The left side is always statements, and the right side is always reasons. You always start a proof with what you're given. So step 1, I was given that AB is parallel to GD. And the reason for that is because it was given. Now I'm looking at this picture and I notice that angle BCH and angle CHG form a backward Z. And we talked in previous videos about Z's and backward Z's. They show you that you have these things called alternate interior angles. And we know from above that alternate interior angles are congruent if lines are parallel. So we can actually prove this in 2 steps. Our next step is that angle BCH is congruent to angle GHC. And again, our reason is because parallel lines form congruent alternate interior angles. Our second proof, again, gives us parallel lines. AB is parallel to CD, and these are actually segments. They have endpoints. And our goal here is to prove that angle AGH is supplementary to angle DHF. So you can see that these are neither corresponding, nor alternate interior, nor alternate exterior, nor same side interior. So we actually really have to look at this proof. But first let's start with our T-chart again. Remember again, statements on the left, reasons on the right. Start with your given. AB is parallel to CD. And now we're looking at this proof to see what we can find next. If I'm looking here in this picture, I notice that angle DHF corresponds with angle BGH. So I'm going to mark that and then I'm going to state it in my proof. Angle DHF is congruent to angle BGH. Think for a second what type of angles they are. Corresponding, alternate interior, alternate exterior, or same side interior. We can start our reason with parallel lines form. And now we have to remember that these are corresponding angles. If I were to pick this angle up, this one here, and plop it down on top of these angles down here at the bottom, angle BGH would fall directly on top of DHF, showing me that they are corresponding. So here parallel lines form congruent corresponding angles. step 3. Now that I have congruent corresponding angles, I can look at the angle that they want me to find, angle AGH, and I see that it's plopped right next to, it's adjacent to angle BGH. And I remember thinking back to a couple videos earlier that two angles adjacent next to each other on a straight line are supplementary. So I'm going to state that in my proof. Angle A, oops, that was a bad angle, AGH and angle BGH are supplementary. And this is because adjacent angles on a straight line are supplementary. Okay, so now that I know that I have supplementary angles right next to each other, and one of them, BGH, is congruent to another angle, DHF, I can use a property called transitive or substitution. They're kind of one and the same. It's just kind of personal preference, which you use here. But I can use that property to help me say that angle AGH is supplementary to angle DHF, which is our proof statement. And I'm going to explain why we can use this property called transitive. Again, another word for it is also substitution. Okay, so again, here we had angle AGH that was supplementary to angle BGH. But we knew that angle BGH right here was congruent to angle DHF. So because those two angles are congruent to one another, I can also say that angle AGH is supplementary to angle DHF by a substitution property. I'm simply substituting angle BGH with angle DHF because they're congruent. So again, substituting these two angles, swapping them out with one another to show that angle AGH is supplementary to angle DHF. In number 14, we are given that AC is equal in length to BD, or DB. Remember, whenever you have a proof with a given, you want to mark up whatever it is that they give you. So here I'm going to start my T-chart. My goal is to prove that AB is equal in length to DC. So I've got my first statement, first reason being that it's given. My next step is to look at the picture and see how can I get AB, this piece here, congruent to CD. If I'm looking at the picture, I see that I have AC and BD that overlap, they share BC. So I want to state something about BC. BC is in both of the segments. So if I talk about BC in terms of AC, BC in terms of AC, let me sketch this out real quick. I'm just going to kind of separate these segments. So I have segment ABC, which is here, drawn below, and segment BCD here, drawn below. Again, BC is in both of these segments, so I can say that BC is congruent to itself. And the property for this is called reflexive. I always think, okay, if I see myself in a mirror, it's called my reflection. So here, if segment BC is congruent to itself, it's seeing itself in a mirror, so it's reflexive. So then the next thing that we want to do, I'm just going to erase a little bit here, is think about how can I prove that segment AB is congruent to segment CD. I know that these whole segments AC and BD are congruent to one another. And I also know that BC is in both of them. So if I think about how to get AB by itself and how to get CD by itself, I'm either doing one of two things. I'm either adding to get a bigger segment or subtracting to get a smaller segment. So if I start with whole segment AC and I take away BC, it's gone. I'm only left with AB. And if I do something similar to the other segment, I start with whole segment BD and I take away BC again. I'm only left with CD. That means that AB must be the same as CD by some property called subtraction. In number 15, we have another proof where we're going to start with our T-chart. I'm going to use S and R for statement and reason. This given is kind of long, so I'm just going to draw an arrow here because I have very little space, but you should be writing out the whole given. If you don't, you're losing points. So here I'm told that ray BG is the angle bisector of angle ABC. So I have to remember angle bisector divides an angle into two congruent angles. So if BG is the bisector, that means that angle 1 is congruent to angle 3. So I'm going to write that down. And our reason is that an angle bisector divides an angle into two congruent angles. I'm going to keep reading. I've got ray EH is the angle bisector of angle DEF. So this ray is bisecting the angle, which means, again, that I have two congruent angles. Angle 2 is congruent to angle 4. Notice that I'm putting this in step 2 also, because the reason's the same, so there's no purpose in repeating the reason, writing it out twice. That's just going to cramp your hand up. So I'm going to leave it in step 2, and now I'm going to move on to step 3. They also told us that angle 3 is congruent to angle 4. So based on my markings, I have angle 3 with one hash mark and angle 4 with one hash mark. So here, because angle 3 and angle 4 are congruent, that means that all of the angles are congruent to one another. So here I'm going to say angle 1 congruent to angle 2, congruent to angle 3, congruent to angle 4. And I'll give you an example of that with numbers. If angle 3 was 30 degrees and angle 1 was 30 degrees, because remember they're congruent because of the angle bisector. But I also knew, again, from the given that angle 3 is congruent to angle 4. So over here, I know that angle 4 must be 30 degrees. Well, we also had a bisector over here, so that means angle 2 must be 30 degrees. So all four angles are congruent to one another by this property, again, called transitive. Now our goal here is to prove that angle ABC is congruent to angle DEF. If I know that every single little piece in both of the angles are congruent to one another, then I can use the addition property to show that the whole angles are congruent. Angle ABC is congruent to angle DEF by addition. Again, I know all parts 1, 2, 3, and 4 are congruent to one another. And if I take 1 and 3, I add them up, it gives me angle ABC. If I take 2 and 4 and I add them up, it gives me angle DEF. But remember, all of these parts were congruent, so that means this whole angle here is 60 degrees and this whole angle is 60 degrees. So therefore they must be congruent. Moving on to our last proof. Fill in the missing reasons below. Given line segment CE is parallel to line segment BF, and angle CEB is congruent to angle BFA. Oops, BFA was not that one. BFA right here. Alright, so first step, CE parallel to BF is given. Second step, angle CEB is congruent to BFA. Remember that was the second part of our given, so we're just going to repeat the word given here. Sometimes people like to split up the givens into two different statements depending on their own personal preference. I personally like putting it all in one statement because, again, I don't want to repeat myself, but it's up to you, whatever you want to do. Number 3 says angle CEB, let's find that, CEB is congruent to angle FBE. So if I'm looking at these angles and remembering that I have some parallel lines, I want to always try to find a Z, and I just found one, because that means that I have some congruent angles if my lines are parallel. And remember that the given said that they were parallel. So here I'm just going to say parallel lines form congruent, and now we got to think about the type of angles that they are. If we're making a Z, in those crooks of the angles we have alternate interior angles. Form congruent alternate interior angles. Step 4 says that angle BFA, this one down here, is congruent to angle FBE. Angle BFA is congruent to angle FBE. So this reason is that we have the transitive property. Remember that originally we had this angle. Let me get a different color here. We had this angle CEB in red, congruent to this angle down here, BFA. Then we found that this angle, again CEB in red, was congruent to angle EBF, now also in red. So because all of these angles were congruent, I can say that these two are congruent to one another because of the transitive property. And our last and final step is to prove that BE is parallel to AF. And again, I always want to try and find a Z, and I just found one. Although it's backwards, it still has the same concept. So here, because I have these angles congruent, I know that my lines are parallel, because congruent alternate interior angles form parallel lines. And again, they're alternate interior because they made that bright green Z.